Let's get back to dissecting this computer and move on to the graphics card and GPU, which is also the brain of the computer. Well, actually this analogy doesn't really work very well, but anyway. Opening the graphics card, we see another PCB with the GPU's integrated circuit in the center, VRAM chips all around, and the voltage regulator module on the side. Above the IC is a heatsink with a fan to dissipate heat, and on the side of the graphics card are HDMI and display ports, a PCIe interface, and then on the other side is the input power connector. Let's focus on the GPU integrated circuit, which, similar to the CPU, has more than 1,000 solder pads that connected to the PCB. Opening the packaging, we find the GPU die, which is noticeably different from the CPU. In here are approximately 11.8 billion transistors organized into 6 graphics processing clusters, totaling 28 streaming multiprocessors. Each streaming multiprocessor is composed of 128 cores, resulting in a total of 3,584 cores. Each core has sections for integer and floating point arithmetic, and sections for queuing in the operands and collecting the results, and is far simpler than a CPU core. Additionally, on the die is an L2 memory cache, shared among all the graphics processing clusters, a set of memory controllers that connect to the VRAM located around the processor, and a PCIe interface for connecting to the CPU. When we zoom in to see a nanoscopic view of the integrated circuit, we find something very similar to what we saw in the CPU, with the transistors on the bottom and a labyrinth of multiple layers of metal wires above. All these structures are manufactured in multi-billion-dollar semiconductor fabrication plants, or fabs, but that's a topic for a whole different video.